Good morning, good evening, good afternoon, depending on where you are. My name is Mate. I'll be your host today. Today is February 29th, although in my case it's March already. But let's stick with the February notion for now. We have one topic about configurable job failure reason for pod failure policy. I see that both Abdullah and Daniel are present. Can you folks walk us through the idea behind the SCEP, and then we can quickly jump to potential solutions and figure out the path forward with this enhancement.
Sure. Yeah, I can just give some brief background and then open it up for discussion. So for anybody who has no context on this, essentially we submitted a KEP, basically proposing that we add an optional like reason field to the pod failure rule, pod failure policy rule. So basically the use case here is for higher level APIs such as JobSet to be able to ingest more granular failure information about the jobs that they're managing and understand, for example, like what specific container exit code triggered a pod failure, which then triggered a job failure via the pod failure policy action. And so the original proposal was just like an optional reason field in the pod failure policy rule. There was some concerns about opening up this field to be arbitrarily set to any arbitrary value by the user, rather than just being a like system controlled field that has like a discrete set of values associated with it. There's some concerns around like validation and having to like continually patch the validation and stuff, is my understanding. And so there's some alternatives proposed, such as maybe adding a new field to the job status. Maybe there's more precedent there for having that be a configurable field by the user. So personally, that alternative is fine with me. I think someone mentioned maybe we could try that, or one of the other alternatives is like an alpha feature and then see how it works. And only if there's some kind of problem that arises from that approach, then we would reconsider opening up the reason field to be set by the user. Yeah, that's just kind of the high level summary. So with that, if anybody has any thoughts, or if Abdullah, you want to add anything, please feel free to jump in.
I'll maybe add the reasoning because I was one of the person uh, that was skeptical with regards to opening up the conditions and basically opening up the shape of the condition to users.
Mm-hmm.
Um, there is a in parallel cap that is being processed for 130, which opens up job to for the possibility to be managed by an external controller. I can't remember off the top of my head the cap number, but if you look for managed by or some
Mm-hmm.
sort of that in the issues, well, actually, I can probably find it quickly. Um, that I think it's related with queue and job set. That basically allows us to have an external entity that will be managing the job restorers. So theoretically, it will open up the opportunities for anyone to write their own third-party job controller. And for that to make place, uh, first of all, we need to make sure that we have very strict validation to ensure the job API maintains the current behavior. So that includes a lot of validation around the conditions, proper transition between failed and a successful job, ensuring that all the fields that we currently were only set by the job controller uh, maintain like reasonable values when they will be managed by the external controller. So that was one of the reasons why I was this is the number, the job API managed by label. Um, that was one of the reasons why I was rather skeptical of opening up yet another field within the job status to be more like a almost open to entire world to write whatever they want. That's why I was initially leaning towards, well, maybe we should uh, programmatically construct the shape of the reasoning to provide that additional level of details about failures such that users will be able to react to them.
Mhm.
I don't remember who came up with the idea of adding yet another field. It might have been David initially in the original cap that is part of the discussion. I will definitely say that that's probably the least problematic and the simplest solution because we can ensure that first of all it can provide whatever a user desires to have in that field, but it doesn't restrict us from the job controller and also in the light of this particular enhancement. And I'll let others to speak. Vanessa, go ahead.
Yeah, I just have a quick question. So just so I understand, the proposal is saying that when you create a job spec, there would be this label, and given that the label is present, it says, okay, I'm gonna add another owner to this job set, another controller. And so does that mean that job set is going to remove itself as the owner, or does that mean that job set and the other controller are both going to be owners? So the object would be deleted, so it has both those dependencies.
You're talking about the managed by label.
Yeah.
That will be such that there has to be a separate controller that will be managing the entire life cycle of a job.
But the user is still creating, I guess where my question is going is why, if you have a controller that is basically going to be managing job sets, why wouldn't you just have that controller create the job set internally? The use case is that you're expecting the job set to be created, from a YAML file, and then it's sort of handed to this other controller, and that controller doesn't want to actually have like the Go code, right, to write the job set.
Job set was one example, but it doesn't have to be. It can be any third-party controller that will be taking over. The example that Mihao was providing me with Aldo was specifically to allow having like a master job and a copy which will be running somewhere else, and then you'll only expose the information in the master job, if I remember correctly.
So I guess I'm trying to step back. I'm trying to think of the use cases. So would a use case be that you have another controller that is somehow doing some kind of orchestration for workloads? I guess what this smells like a little bit is what Q does when it has the mutating webhook and it suspends the job and then it kind of like redirects it. Except this is different just to add this other owner. Oh yeah, the user stories, that's what I should be reading, right?
Yes, Q was one of the main is one of the main consumers behind this. Abdullah.
Yeah, let's step back and see like what is it that we're trying to do here, and first agree that whether it's reasonable or not, and then think about the API. So just to clarify, the improvement that we're trying to do is bubble up the reason for failure, and if we think that this is something that will be useful, that's one first step. I guess we agree that this is something useful, right? Like the reason for the failure should be somewhere in the status, instead of just saying that the job failed.
Absolutely, yeah. At least
Okay.
for me, 100%.
And
Yeah,
it's not just like an abstract
yeah.
reason, but also the detailed reason, right? Like it failed because of like pod failure policy, rule number, whatever, or a specific rule triggered, and I want to know that it was failed because of that rule, not just because pod failure policy triggered the failure.
Correct. I remember that there were no contentions with regards to the
Yeah,
general idea. I
right.
think the only contentions problem was the shape of the API and where we could express that additional information, that details
Yeah,
about what caused a particular failure of a job.
yeah. Yeah, that sounds great. So then the next step is how we're gonna expose this, and I guess a status makes sense. It's a status, and then one option was either a condition because this is where we set the reason for the failure. Now we're saying that the reason is something that is part of the API. It's part of the contract. It's not just like a message with some arbitrary sentence. It's part of the contract. The idea of automatically setting that reason was presented on the KIP. And I actually like it if it can work. The only reason that it has some problems is, consider the case where you have like on exit codes a range, for example. How would we express that as an automated a reason value? It's going to look clunky, basically, in some sense. And the use case here is that the user might need to use that value. So the other thing here problematic is that they will have to guess what it's going to be, right? Like they have to look at the documents and say, okay, this is how job is going to generate the reason when this rule that I wrote triggers. And that also creates like possibilities for errors and problems, right? That is why we proposed having an explicit field that says, if this rule fail, then set this reason. And in some sense, I think we can think of it as a rule name. Like if we give the rules names that are distinct, then that would solve the problem and set that rule name in the reason. So you can think of that that we're trying to add as the rule name. Right now, the rule doesn't have a name. So if we add a name to it, wouldn't that make it less perceived as just arbitrary value? And then we validate the name and so on and so forth.
I think in general the status the separate status field allows us for a lot more flexibility with regards to what we can present. The conditions are, at least in the initial form, they are very restricted because there's usually only a reason and a message. And reason we're trying, at least in the majority of the cube, to keep a bind together set of words that's supposed to be machine readable. Definitely adding the names within the pod failure policies would open up the field of debuggability a lot more to users to figure out what's failing. But I would not, especially that this API already exists. I don't honestly remember at what stage we are with the pod failure policy, whether that's beta or
I think
close
it's
to
beta.
GA. Yeah. So we probably want to keep the backwards compatibility in one way or the other, which doesn't stop us from adding the name there. But we have to be prepared in cases where those names are not present, in which case I'm guessing we can rely on the index of the rule.
Right. And
But yeah, definitely naming will make it more readable if we want to go that route. Or I mean, if whether that would be because in the proposal, the part where I currently have the set condition reason, if
yeah,
we change that to the name, and
yeah,
in this way, everyone can always check, the author can always check, oh, this is actually related with this particular name, with this particular failure condition, and then figure out. And then if 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 required, uh, just from coming from the fact that we are working with an entirely new field, we can expand the field with some additional information. If we want to have that kind of flexibility, and definitely a new field will allow us to have that extra flexibility.
So, uh, uh, so in this case, like here, we're saying it's set condition reason. If we change this field to name, okay, and then they give them names, and the name we
Yeah.
say optional, it's by default set to the index of the rule. So that's how we can work around, like, backward
Uh-huh.
compatibility. And then we use that as a suffix to the reason we inject in the status. Or you still concerned about uh, setting or changing the reason in the status in this way.
Okay, so you're basically saying that we would put a name on the rule in the pod failure policy,
Yeah,
which would default to basically the index,
right.
and then we would inject either the name. Well, in that case, if we would be considering injecting the name, then probably a separate field would be better. But if we would just only stick with the indexes, then the index could be part of the reason, of the condition reason, not a separate field. Because I what I'm trying to prevent is a situation where um, we will introduce a name field. A name field can be, I don't know, 250 characters, give or
Mhm.
take. I don't remember off the top of my head the exact limits that we have in place. And you use that name as part of the reason, which suddenly makes the reason, which is, I don't know, pod failed. It'll be pod failed an extra 250, which might end up
Yeah,
overflowing the name of the reason
but the
and
name
make
could be, we can validate it's much shorter as we wish, right? Like the name field inside the rule, do we have to make it 256? We can make it like limited to 20 to 30, some reasonable number. Like upon and then set that like in as a suffix to the reason.
But do we actually need the name in that case? Isn't the index overall uh,
Yeah,
being part of the reason sufficient in that case?
the index is, to me, is like the backward compatibility escape hatch, because
Mhm.
like ideally if I'm doing like pod failure parsing now, I would set name as required and make it like unique, right, in the rules, so basically like a map.
Mhm.
But we don't have that. And then why would I prefer to have the name? Is because again it's more readable, like, and it's like an index. Again, you might set 0 instead of 1, etc. A name is, self-descriptive.
Uh, I mean, I could probably uh, get convinced to the name, but with very strict validation that we will ensure that this will be only, I don't know, a single word,
Mhm.
I don't know, with very short name, 20
Yeah.
characters max or something along those lines. I would probably try to make it not super long. And 20 characters is usually sufficient. In that case, I think that could be that could work. I'll let Kevin speak up because I see he has his hand for a while. Go ahead, Kevin.
Yeah, my main one thing I was wondering about, like the goal of this is for like, I mean, I know it's not one, but job set was one example where we were trying to like kind of programmatically control whether we restart a job set or not based off the job. We have a focus here on the pod failure policy. Is there uh, are there any things like having a smarter control over like a back off limit or active deadlines and having setting failures based off of that? Because this seems to be targeted for pod failure policy. But what I'm wondering about is other cases where jobs are failing. Do we want to have conditions set in that case?
I mean, I'll give my opinion. My opinion, I guess, would be if there's like a concrete use case for one of those other reasons that could be feasibly useful to job sets, like trying to more intelligently decide how to handle the failure, like if we should restart, if we should restart only like one replicated job or whatever, then maybe. I currently don't have anyone. If you have one you'd like to share, that'd be awesome. Yeah, I also was just trying to keep the scope of this like narrow and focused, so to speak.
I
But
feel
it's
like
also
that's
good.
bridging into the, so there's always this fine line between like, okay, we're creating like this unit of work, and then we're doing something that a workflow tool would do. And in my mind, the specific pod failure policy, this falls within the unit of work, but the thing that's executing that is gonna get back, okay, this named rule, this failed, and then it's that tool that's gonna make the decision about what to do next. And I think trying to embed all of that logic in like this one job set custom resource, I think that's going into the sort of jurisdiction of the workflow tool. So that would be my argument of where I draw that line.
Yeah, I think generally, I mean, if the pod failure policy is the main one, I can see value in going forward with that one. I just wasn't sure if I don't have any use cases off the top of my head, but like if there's enough we have for like an active deadline or back off limit to kind of control that, because that's the only thing I'm worried about with the pod failure policy is one example, but if there were others, like would we want something more general, like in a status field, or that was my main point.
So the mechanics exist, right? Like the reason field exists, and what is being proposed here doesn't lock us out from expanding this into other failure scenarios and addressing them in the future. Pod failure policy is a very concrete, failure reason with more details about like why pod failed, and so we're addressing that. The other cases where that would cause the job to fail, they have their own reason prefix too, right?
Okay, yeah, I
So we
forgot
can
about that.
expand
So,
them. Mhm.
sorry, I forgot about that.
Yeah,
Yeah, that we are setting those reasons for those
yeah.
cases.
They have their own reasons, right? Like the pod failure policy has its own reason that we are appending to it a little bit more detail.
Because right now your problem is you have pod failure policy, whatever, and then you don't really know if it's an on condition or an exit code or what. So you can't really programmatically control it at the job
Correct.
set level.
Correct. I guess as a next step, like if like Daniel and we change the proposal to present it as a name where the default value of the index when not set, um, and then we discuss whether that's going to be a suffix to the existing pod failure policy reason or a separate field. We would discuss that in the KIP. That
Yeah, that sounds reasonable.
okay?
I would probably try to. I know that next week is code free, so folks probably will be primarily focusing on closing 130. But as soon as that happens, I would probably try to push together this cap and get it in a shippable format even before 131 starts, so that we can get it quickly, figure out the details of the cap, and then only follow the usual process and get it queued up for merge quickly in the early stages of 131.
Makes sense. Thanks.
Cool.
So can we
Thank you.
tie this back to the owner or the managed by label? I think we were originally doing that, and can we tie it all together?
The managed by is currently being worked on as part of 130. So if you're curious about the work, I'll link this in the agenda. You can track
So
both
are
the
these,
cap.
what we just talked about with the reason and for pod failure and the label, are those different, entirely different things?
Yes, those are
Okay.
those are two separate enhancements.
Yeah, I think Maciek's point was about the manage by is having separate controllers might be doing validation, and they're sort of making sure the contracts don't really change too much. And I think that was the main point with the manage
Yeah,
by.
yeah, yeah. That was basically the potential interactions coming from both of those caps overlapping to some degree might be causing some unexpected issues in sometime in the future. That's why I was trying to ensure that we have a better understanding of the overlap and make sure that one doesn't bother the other or break us in some unexpected ways. Okay. Does anyone else have any questions related with CAP 4443?
Nope, that's all I had. Thanks for the
Cool.
discussion, everybody.
Thank you very much.
I guess I have one kind of higher level question. People are going to be making names for failure reasons. A lot of times those will be linked to specific exit codes. And I'm wondering if there is a desire or need for, I don't know, some kind of simple, I don't want to say standardization, that is a dangerous word, but some kind of, not enforcement, but a suggestion for consistency for how that's done. So for example, there are common exit codes for different applications that, if two people implement it, they might use the same exit code, but then they might have a different name. And so what can we do to help make that more consistent so that they might use the same name?
I don't think we need to. Why would we need to enforce? Like, it's like enforcing naming on.
No, I didn't say enforce. I don't mean enforce. I mean, I guess this is probably more a question for the community of people using it. How can, like, let's say, for example, that you're developing a workflow tool that's going to be intelligently using these reasons, and maybe there's a common underlying thing that has a common set of exit codes. Maybe what you would do is you would put a markdown file on GitHub that says, okay, here's my exit codes and what they're called, and then suggest nicely, not enforce, that people use it. So there's just consistency between that. I don't know. This is just thinking about the wild west of these rule names that is going to develop from this, which is probably fine, right? But maybe there could be something a little more organized than that.
I think a lot of naming suggestions, like what you're saying, will be in the hands of either platform owners or the users that will be primary, the users of a particular uh, system. I don't think we as I'm always thinking from the kube controller owner perspective, or basically kube contributor perspective. I didn't think I want to be in the on the ship where it says, well, you have to do it this way or that way. What we can do, on the other hand, is we can put appropriate validation in place, and that was my original concern about opening up the reason for like full blown whatever people want to set there. Um, but there's certain limit with regards to validation that we can put in place, because you always have to weigh the usability with the possibilities that any kind of approach will give you in in the future. Does that make sense?
Yeah, and to be clear, I'm not saying that the, you know, the working groups here should be managing something or enforce anything. I'm thinking also that this is on the level of the user, and what it's analogous to is with open containers, when you have like annotations. There are a few annotations that are maintained by open containers, but for the large part, it's a wild west. And I think that just, even if in like some documentation somewhere, we say something like, if you're, you know, maintaining some kind of infrastructure application, like just think about this for your user base. Think about like what you want these to be. Because I do think that having some kind of organization or consistency, again, maintained by the user, not us, is not such a bad idea.
Oh yeah, I definitely agree with what you're saying.
Yeah, as we're talking about this, I do kind of wonder about like I guess the one use case I've heard of people using are like exit codes based off of like OOM and kind of knowing whether or not to like this. I've seen cases where if your container is getting OOM, people had it in their workflow managers bumping the requests and limits based off of that. Don't know if I like that idea, but like there are some, like there's like the Kubernetes, like uh, even OOM's not even really caused by Kubernetes in that way. But sometimes like there might be exits caused by Kubernetes versus like application exit codes. But I don't even know how well standard it, like what exit code you get from a container if it's OM killed, if that's really standard across container runtimes and other things like that, to be honest. So I don't know. It's a hard question.
Yeah, I don't think we can standardize anything. I think we can suggest to users that they think about the labels and, or sorry, the name of the rules, and they name them in a meaningful and intelligent way that might reflect, for example, that use case.
Yeah, makes sense.
Okay, last call. Any other questions? Okay, cool. Hearing none. Vanessa, you wanted to talk about Q. You still want to
Yeah,
cover
I'd
the
love
topic?
to. So this is informal. Is that okay?
Yeah, go ahead.
Okay, is it okay if I share my screen or?
Yes, of course. Give
Oh,
me
it
a
says
sec.
it's disabled.
Yeah,
No.
I need to
Can
give
you
you
give me the powers? The
yes,
powers of the share.
I'm just doing that. Now you should be able to share your screen.
Okay, before I share, since I can see all your little name faces, or not your faces, but your names, can people raise their hands if they have interacted with some kind of workflow tool? Let's first start outside of Kubernetes. Who here has used a workflow tool outside of Kubernetes? Raise your little digital hands. Okay, I see 2. Got to be more than that. Okay, now I see 3. Kinda. All right. Who's used the workflow tool also in Kubernetes, like Argo or Q pipeline? Okay. So folks are generally familiar with this idea that, you know, I guess we can take an example of like a scientific workflow in biosciences, where there's like the steps of processing data. So you start with your raw data, you do pre-processing. Actually, maybe machine learning is a better thing, where you have, you know, different stages where you're starting with raw data all the way through training a model. That's probably the better example. So HPC, or just generally like the scientific community, has been doing this for a really long time. And starting like more than 10 years ago, early 2000s, sort of when the clouds were starting up, they started making these workflow tools that would explicitly be able to submit work to cloud VMs. And so has anyone heard of SnakeMake, Nextflow, Cromwell, CWL? Raise hands, anyone? Okay, that's good. Two people, 3 people. This is great. Okay. So these tools have been very common and used in the scientific community for a while. And so what's kind of happening now is with Kubernetes. So Kubernetes originally was for like running your website and keeping it running, right? It was basically sort of, it didn't have this concept of a job. So of course, that's when the batch working group came about, and now we have this concept that we can actually start and complete things, which is really fantastic. And what we're sort of seeing now that's reflected in a lot of these discussions is there's this tension between I'm submitting this unit of work, but now I have something that smells a little more like a workflow. So the unit of work might be sort of, for example, this new launcher worker design custom resource where you have things that are really kind of working together in one unit. But really a more traditional workflow is you have steps, right? A needs to finish before B and C, et cetera, et cetera. So what I want to share with you today is, I guess, the start of discussion for what we kind of want this future to look like. So let me now try sharing my screen again. See if it works. Oh, I clicked the wrong button. Desktop capture. Oh, this is different. Hope I don't screw this up. Dell. Okay, can you see my screen?
Yes, we can.
Yes. Okay, great. So let's see, you're familiar with Argo. Actually, a lot of those workflow tools have really nice interfaces. So here, I'm gonna talk about SnakeMake because that's actually the first one that I prototyped that I want to share. So many of these workflow tools, this is actually really interesting design. If you look across all of the ones that I just named and actually others, what has happened over time is that people have figured out that, like, you want to have a workflow tool that has your DAG, your directed acyclic graph, where it says like, okay, step A, B, C, et cetera, et cetera. But that DAG is actually going to be submitting work somewhere. And actually the somewhere is a variable that changes dynamically. And so most workflow tools that I've encountered, they call these executors. And so they have these executor backends. So this is, for example, SnakeMake. All of the executors are implemented as plugins. And so for these executor plugins, these are the places you can run work. So you have traditional HPC things. So Kubernetes, sorry, not Kubernetes, Slurm is HPC. Let's see, Flux is HPC. DRMMA is like a cluster. But then you also have cloud ones because cloud is a thing too. So we've been submitting to, so for example, Azure Batch. Google Batch used to be the life sciences API. That's getting deprecated. Now Google Batch is taking over. There is a Kubernetes executor. Anyway, so the high level idea is that we can actually, and there's kind of two directions this could go in, right? So when we're trying to design workflows to run in Kubernetes, we could make entirely new tools. You know, sometimes that's fun, sometimes that's okay. But there's also, actually, let me show you Tommaso. There's this great GitHub, awesome workflows. Let me show you how many workflow tools there are. So there's some precedence here for running things. And so the question is, do we really need to make another new thing? And I'm going to argue that there's a lot of pipeline tools, workflow tools that exist that we can actually use because we can programmatically just kind of insert our abstractions. And so to start with SnakeMake as an example, I created a queue plugin for SnakeMake. And let me quickly show you what a SnakeMake job actually looks like. So a lot of these tools have like some kind of file where you define your job, right? So SnakeMake has the snake file. Guess what that's based off of? A make file, except it's for Python. It's a great name. So this is a very stupid rule. Or sorry, this is a very stupid snake file that's going to run. Well, this is a hello world one. Let's look at the lamps one. That's more interesting. Have folks heard of lamps? Anyone? So lamps is basically something that's using MPI, collective calls. It's like a bread and butter HPC thing. It's this LMP lamp thing here. So this is actually a snake file that's going to run the Flux operator, which is a Kubernetes CRD that we developed, and it's going to run lamps. And so the basic idea, you can see what that looks like here. For a lot of these workflow tools, you basically launch it, and then it will, show you something's going on, it's active, and it finishes like that. So what does that actually mean? It means that within SnakeMake, you have a generic, is this too small? It's bigger. Enhance, whoops, didn't want to do that. Okay. It means that you have this kind of interface for an executor based off of, the parent class. And then there's generally, there's generally functions. I don't have to go through these in detail, but there's generally functions to like run the job, get the status of the job, and then kind of make decisions based on that. So for example, in this run job, this is actually going to figure out what kind of operator it wants to use. So Flux operator, the default is actually just using a standard Kubernetes job. And then we bring in the custom resources. So here I have a generic Kubernetes object that extends into also a batch job. And actually I have not done job set here. I could do job set here. And then the Flux mini cluster, the Flux operator. I attempted to do an MPI job, but I never got it working because it's pretty complex. So here's my thinking. I think that we can take a lot of the workflows that are currently being run or workflows to be run and think about how to extend what we're working on. So basically using various language APIs to add them to these workflow tools that already exist, such as SnakeMate. And the hardest part is probably like, which ones should we choose? Because there's like 10 gazillion thousand. Anyway, what are folks' general thoughts? I've just been kind of talking off the top of my head. You still with me?
Yeah, this was actually my start into Kubernetes, was trying to build a workflow engine between Slurm and Kubernetes. So I used, in my case, I used CWL coupled with Argo workflows on Kubernetes, and then I forgot what I used for Slurm. Oh, I used something called Toil from Santa Clara, and that was at least what I used for the Slurm side. But I remember the hardest part for the workflows between cloud, on-prem, and Kubernetes was around like auth and setup and actually getting these things set up in a way that wasn't painful. I know you've also, I think, talked about storage as another case that.
Oh man, that's the worst one. Yeah.
So yeah, I think I was always kind of curious. I saw very few that actually have support for both Kubernetes and Slurm. And so I know
SnakeMate and Nextflow do.
Yeah, those are the two, and then Cromwell sort of.
Cromwell's kind of old school. I guess I shouldn't speak poorly of Cromwell, but I don't really use it.
Yeah, I think what's interesting is this was a lot, for those that don't know, a lot of these tools were, at least from what I saw, they came from like bioinformatics is a big one around having all their CLI tools containerized and connecting them into tools. So there was a lot of work from that community, and a lot of the workflow engines that I saw work pretty well in the cloud came from those groups. Now
Yeah, so that's a good point. There's a repository called Biocontainers. Biocontainers actually delivers I think over 8,000 or maybe 9,000 now, different kind of containerized, scientific applications. They're mostly in bioinformatics or informatics that just do plug into these tools quite nicely. And it's an interesting cultural development because all of this work for sort of the biosciences and workflows started a lot earlier than other scientific communities. So way back in 2011, 2010, at least that's when I was sort of starting to be aware, but it could be sooner than that. And when the reproducibility crisis happened, which was oriented at psychology in 2014, 2015, those particular communities weren't really latched onto that cultural movement yet. So they weren't using that tooling in the same way. But then that changed. So neuroinformatics has really good kind of reproducibility now in terms of databases and containers and orchestration. But guess who's lagging behind? It is HPC. We haven't even figured out like the workflow tool yet. And actually, if you look at a lot of these workflow tools, their DAGs and the way they generate pipelines is not intended for HPC type work. So like it's very rare to see something with MPI. SnakeMate did recently add an ability to support it, but it's only been very recently. And so that's why, for example, with like the Flux operator that can handle MPI, all of a sudden you don't have to worry about like figuring out MPI and Kubernetes beyond having a good network. If you don't have a good network, you're in trouble. But you would just say like, okay, for this particular step, just use the flux operator. And so we can put the things together kind of like Legos. And I guess the missing piece though, you know, of course we could do sort of what I just demonstrated, taking, you know, the Python or whatever language you want, implementing it inside the workflow tool, having that be a backend executor. But the other thing that I think is really interesting that I've been thinking about is that Kubernetes natively is more about kind of it's more like a state machine, right? And one interesting thing, if you look across that huge GitHub of all those tools, is that those are all very DAG oriented. And it's not that DAGs couldn't have like subgraphs that act like state machines, but I feel like there's also an opportunity to build some kind of workflow tool that's actually more state machine oriented, specifically for Kubernetes, because Kubernetes is really good at that. So just some thinking I've been doing.
Yeah, this is pretty interesting. I'm more like a web services guy from Kubernetes, Mesos land, and now I'm kind of getting into the AIML side of things. So yeah, it's like interesting seeing kind of what HPC has already brought in, or like what has kind of already existed. But from the Kubernetes side, like we're definitely looking at Argo workflows, queue kind of stuff, and figuring out. We also have the Slurm side of the house, what to do with that exactly. So yeah.
Yeah, and queue is actually just like literally the queuing part that then is separate from the scheduler, which then has to take into account like topology and like it's a complex picture, but yeah, I don't think I have sort of like a, you know, I'm not standing up here like let's do this project or have this idea, but it's something that I think our community should start thinking about. I'm probably going to start prototyping things and thinking, and I'm sort of new to like how you propose KEPs and stuff like that. I'm more of the kind of person that will like implement something in a weekend and put it on GitHub and then like yell about it and ask people for feedback. But if there are folks in this call that I guess sort of I think a good start would be to just have even offline discussion about what our needs are for workflows. Like for example, at my lab, we have a lot of very heterogeneous workflows. So there's like a simulation component that goes to some kind of service, which machine learning. And we traditionally have always run that sort of, you know, bash scripts hacked together on different HPC clusters. Like it is a mess. You know, it's not great. But we really like Kubernetes, and actually some of the work that we've recently been doing with Usernetes, so running Kubernetes in user space, because we can run it on our clusters, and then being able to kind of combine those two worlds. But there's still that missing component of like, what is doing the orchestration? Because it's not going to be a job set. Job set might be involved in there somewhere. And actually, I will add job set to queue, but there needs to be some glue that ties it together. And ideally, that it will work for use cases that span across cloud and HPC and all the other communities that are out there that exist or don't exist. Just like listening to bands that don't exist yet. I speak for communities that don't exist. You know, I'm just kidding.
So the one thing I think might, I actually think I remember seeing a feature from Matchek about this from a long time ago around, there was a proposal to try to make a workflow in Kubernetes, which was denied. So I don't
What
know.
What does it mean when it's denied? Does it just mean he got like tomatoes thrown at him and he was like, okay, I'm sorry guys, it was bad, I'll run away now?
No, that was very early on. After we implemented the job, which it was very early on. One of the first releases of Cube already had jobs. It might have been like 1.2, 1.3 was one of the first betas. So we got the job, and then we switched with a friend of mine, Dario. We switched over to workflow. We went with the workflow, and then the workflow proposal eventually merged. It wasn't called CAPS back then, even at all. And then we had a follow-up discussions with various folks from various companies, and then we agree at the time that the workflow is probably a lot more complicated than what we put together in that proposal. And we didn't want to, and at the time, a lot of folks already were running some kind of workflows tools. And rather than reinventing the wheel again, we said that we will provide the primitives, and then everyone that either are already using their own workflows mechanism or are considering, they will just inject and try to build on top of Cube. Uh, and yeah, 8 years later, we're where we are, I would say, but something along those lines.
Yeah, and I think that design strategy provide the units that some other tool can kind of use. That's sort of what I was demonstrating with SnakeMate. So maybe it would be interesting if folks that have things that smell like workflows, if we can just share them. And then I think sort of what I want to do as sort of a mental exercise is to look at these workflows and to look for common patterns of execution. So for example, the launcher worker design, although that's a unit in a workflow, it's sort of a common pattern of how we're doing things. And I think there's probably other common patterns like that that are sort of one level up from the unit of work that we might think about. And I don't have a plan beyond that because I usually only think 1 or 2 steps ahead, but that's sort of what I wanted to share.
So I guess one thing I'm curious about, what workflow engines are people like have used in the cloud native space? Like I know Argo is a main one I can think of. It's one I've used. I don't know if like, I guess there's Kubeflow pipelines, which actually uses Argo under the hood, I think. So I wonder, like, it does seem like the cloud native doesn't really talk to Slurm and vice versa. So I think that was the issue that I saw, was there were very few, but I was curious of what people have found their users actually are interested or have been using for some of the folks that are here on the call.
I found one and I can't remember the name now. It was like, I keep thinking like Falco, or it wasn't Falco. It was, my God,
Flight.
What was it? Flight. Yes, it was Flight. I found Flight, Argo, and pipelines. And those were like, I guess then there's also like Apache Airflow, but I sort of stay away from Apache Airflow because I find it a little bit scary. But those were the main 3 ones that I was sort of looking at and thinking about. Okay, but I think the problem is I don't really have a sense. The question that you just asked, I don't know the answer to it. Like I don't have a sense of what, what even across like national labs, I don't know what people are using consistently for workflows. And I definitely don't know that answer across like, industry and companies. Like maybe we're still at the point where most people that are doing machine learning stuff, like they're fine with the kind of the unit of work abstractions that we have. And then for their later steps, they do what everyone does, which is like cobble together some Python scripts and, make it work. But maybe there just isn't. Oh yeah, Ace, go ahead.
Yeah, I mean, just that really triggered something for me, which is part of why I'm here. Like, I joined an AI/ML company a couple months ago. It's been really illuminating to see how they do, or rather don't really do infrastructure. It very much is like this cobbling together of scripts, and understandably, right? Like they're trying to get a job done. But you can see it's like they're not really, it would be nice to have these kinds of workflow tools, but it's not really something that like they even understand how to ask for necessarily. Like they're focused really on the ML side of what they want to do, right? So it's interesting just to watch how they work and like try and figure out, oh, what do they actually want or what will make their lives easier. But I kind of agree. It's like I'm not sure that even some of those users really know what would help. It's like they understand what they need to do, but kind of mapping that to, kind of cloud native workflows like we've been talking about is I think not super intuitive. Yeah.
Yeah, I think that this group's, or at least what I've talked with Aldo and others about, was that one of the goals was to have something like the part of the issue I see is Airflow, uh, Airflow, Argo, and others use pods as the main abstraction for running. Sorry, it's a terrible use of words, but they use pods to run batch jobs. And one of our goals would be to start engaging with these communities to start trying to use the job abstraction and then kind of that way that, like, I know Airflow kind of has issues where they don't do have retries or much like parallelism in their jobs. And so one of the goals from the, I think eventually, was if people have have worked in those communities, is adding some of these abstractions to like Airflow, like rather than the Airflow pod operator, there could be a job operator or something like that. And then I know, I guess Argo is now supported in Q via the pod support, which is cool. But I do know that there was also thoughts of trying to get Argo workflows to actually spawn Kubernetes jobs. That way, kind of at least get it, because like I think right now all the workflow engines in Kubernetes land are actually using pods, and that sort of does cause some challenges down the line.
Yeah, so it's so interesting you mentioned that. I mean, I won't promise anything, but some folks on my team are looking at exactly that scenario right now. Like, can we use job sets or Volcano with something like Q and Argo workflows to do both kind of like the queuing and the prioritization quota pieces all together with pod groups or jobs or something like that, right? Yeah.
Cool. Yeah, that was at least what I kind of saw the main goal of. I guess, Vanessa, I did have one question for you. One thing when I was looking at workflows in Q, generally I was wondering, for queuing in the HPC world, do you queue the workflow or do you queue the step?
No, so when you think of a work, there's kind of two things. There's a workload manager and a workflow. The workload manager is just being given units of work, saying like, okay, I have this job. It could be spawning up an instance that's going to launch smaller jobs, but it needs this specific set of resources. And it's the workflow tool that is deciding upon those units of work and submitting them, giving them to the workload manager at the correct time, that sort of thing. The workload manager is just this dumb thing that is receiving things and queuing them. And that's also what I see. So like a workload manager like Flux Framework or Slurm, that's analogous to queue. And so I think we also have to be careful that queue doesn't turn into something that people are trying to put workflow abstractions in, because it is the queuing tool. It receives the work when the work is ready to go from a workflow, if that makes sense.
Yeah, so I guess the main concern would be around like certain, like if you have one job that needs a GPU, like that can be the main bottleneck if you're in the cloud space or whatever, and you're waiting to get a GPU, and or you might have a really long timeline to get into your cluster.
Yeah, so that kind of request would go into the workload manager, but actually workload, I don't know about Q, but workload managers like Flux do have basic dependency structures. So you can say like this particular piece of work, the one that's going to use the GPU, and step A needs to happen before step B. But you wouldn't like give Flux like an entire workflow and be like, here, Flux, be a be the workflow tool. It's not really designed for that. Or I personally don't think workload managers should be designed for that. Their job is to do the scheduling, the resources, and then to make sure that the work runs and to check in on it. And actually those things should be different components too, but that's a totally different discussion about like the fact that a scheduler and a queue are actually two separate things.
Yeah, well, no, thanks. That's interesting.
Okay, I don't want to interrupt the discussion, but we're at the time.
We're out of time. It was fun though, right?
Thank you very much, all. Enjoy the rest of your day, and see you next time. Bye, all.
Sounds good. Thanks, everyone. Have a good rest of your day.